Hello friends, welcome to the week 6 summary of NCER course. In this week we have to study the interaction of PN junction with radiation. So at first we have to see what is forward bias. When the P terminal of a PN junction is connected to positive terminal of battery, then it is known as forward bias. And when the negative terminal of the battery is connected with the P side of PN junction, then it is known as reverse bias. The IB characteristics, that is current voltage characteristics of reverse bias and forward bias, are shown in this curve. One thing which we have to remember is that solar cell is a current source, not a voltage source. Charge carriers created by sunlight received equal to photocurrent, and that are represented by IPH. So without external load, the PN junction is forward bias and internally shorts. This thing you have to remember, that without external load, the PN junction is forward biased. There are some conclusions that the PN junction stabilizes the electron hole pair, and the PN junction solar cell is a current source and has to be used accordingly. So PN junction solar cell is a current source, not a voltage source. Now we have to see the solar cell characteristics and its usage. There are different IV characteristics we can see from these following graphs. Here BOC equal to open circuit voltage and ISC equal to short circuited current. In this IV characteristics we have to see maximum power point and the fill factor equal to VMPP into IMPP upon BOC into ISC. Now this curve shows the comparison of solar panels, different solar panels. This curve shows the variation of sunlight. And the equation of BOC equal to given gamma KT upon Q ln bracket IPH upon I naught plus 1. Now some conclusions are given that solar cell is a current source, IV relationship is complicated, OCB is not the most important parameter. OCB is not the most important parameter. Fill factor of a solar cell is important. Solar cell must be coupled with an AND use that utilizes the MPP, maximum power point. Now we have to see the solar cell concentration, that is the Shockley-Queisel limit. It says that in unconcentrated AM 1.5 solar radiation with a band gap of 1.34 electron volt, 33.4% efficiency is obtained. And silicon 1.1 electron volt, 32% efficiency is the best, practically 24 accomplished. So black body radiation 7%, recombination losses 10%, spectrum losses 19%, unabsorbed 33%, excess and total 52%. There is a concept of tandem cells, that is high band gap cell, low band gap cell. With several tandem cells and concentrated sunlight, theoretically greater than 80% efficiency is possible using the tandem cells. So the visible spectrum wavelength 400 nanometer to 700 nanometer, corresponding band gaps 3.1 electron volt to 1.8 electron volt. PBS, a direct band gap semiconductor. It is a direct band gap semiconductor. Band gap of bulk PBS, that is 0.41 electron volt. Band gap of a nanocrystalline PBS can be varied to 4.0 electron volt. So the conclusions are: part of a solar cell are designed to increase the efficiency of solar cell. Parts of a solar cell are designed to increase the efficiency of solar cell. Shockley-Queisel limit indicates the limitation of a single junction solar cell. Tandem solar cells can overcome these limitations. So we have to study these conclusions very attentively, because many of the questions are asked from these conclusions. Now I'm going to speak some important key points from week 6 which you have to listen very carefully. That is, a PN junction helps stabilize an electron hole pair. And during forward bias, the space charge region or depletion region decreases in width, and during reverse bias, the space charge region or depletion region increases in width. And without external load, when exposed to sunlight, the PN junction is forward biased. This we have to remember very carefully. One more thing, that recombination occurs in a solar cell. Recombination occurs in a solar cell. And the maximum power point of a solar cell does not occur at open circuit voltage. The maximum power point of a solar cell does not occur at open circuit voltage, and the maximum power point of a solar cell may vary from manufacturer to manufacturer. So thank you very much for paying your kind attention. See you in week 7 summary.